Maybe from
I just recording now. So, but let me just recap for some, at least
okay,
some people just join us now online.
okay,
So let me just go back to my slide. Like I said, piping stress basic as it relates to oil and gas projects. So my focus is not to teach the stress like Caesar, like Intergraph, how to move the board, is to uh, show us how to use Caesar on the live project, what we do in the office, in an engineering environment, engineering office. So, and I'll say our take home is to understand deliverables required to carry out stress analysis, basic understanding of CISA 2 2019 demo. That's the one I downloaded. You can download it too and use it for practice and how to model. Then we have the static and dynamic analysis. Those are the basic, the two analysis carried out in CISA. Then we have, okay, I've shown us the output. That's the one I was trying to generate, the output in CISA. You go to, when you click on analyze, you do your load combinations, and then you check, you can do, if you know how to use the animation, you will see how the pipes are behaving, how they react to each other. You need to, that one you need to study very well to know how they react. How, that's something you cannot imagine. It will show you how they react, which is very key. So from that 3D plot, you can see the growth, the deflection of the pipe. So if the pipe is not flexible, you check all your load condition one after the other, check whether it's overstressed. It will tell you if it's overstressed. Then you can check the maximum stress, where you have the maximum stress. So you adjust your support accordingly, or adjust, or sometimes you can reroute the line to be flexible. You understand? If it's too rigid, you can reroute the line and send it. That's why, like if you are using a Viva A3D, we have the PSI, that's pipe stress interface, that you can send your CII file back to the designer. Designer will just upload, it will just adjust. You understand? Which is very, that's what I call smart engineer. It's good. Before you have to start modeling all over again, but this one now it makes it faster. So our time is running out. So then the other thing, that's the interface softwares. Interface, okay, how interface, I have just mentioned that. Then we have the code and standard, which we need to know. There are so many. So depending on what you are using, if you are using maybe fiberglass type of material or something, there is the type of code that you use. If you are using campus steel, excuse me, stainless steel, depending on the material you're using, so you select the code that suit, or sometimes some company they will specify the code that they want to use. So you have to follow it. Then you can advise too. Then we have pipe support, which we cannot deal with. Pipe support is very is another topic on its own. So then we have the weight and the external forces impact on your pipe. That's part of what we mentioned when we talk of wind load, seismic load, some external forces. Maybe if it's an FPSO, that one's another area that's very, because of the sag and the hog and the deflection of the way the behavior of ships is different, because they are floating, a floating device. So that's why you see the design of FPSO, how they are designed, even the support. If you look at it critically as an engineer, you see that it's different from just ordinary flow station or something, because of the deflection, because of the hug and the sag, and or the way the FPSO rotates. So those has impact on your pipe. And if your pipe breaks or something, because all those forces, you over time to break, your pipe will have a problem. So you have to consider all those. So those are the things when you say pipe code and standard, pipe support, weight and forces acting. Then so because of those forces acting, external forces, internal forces, then that's where you now look at the load combinations that are required for that purpose. Then you do that in your Caesar. So why modeling is just another, just you must just know how to model it. Once you model it exactly the way the pipe engineered model it from your 3D model, get it, then you put the support, you run it and see it. You just do a first run and see, okay, if it's okay, If it's not okay, you start adjusting. In fact, with experience, you can know if you can say, okay, this thing will not be flexible, this one will not be okay. So you check it. But how to check is when you run it, you go to your 3D plot. You use those animation, all those things to check the growth, the deflection, and everything there. That's how to check. So, and with experience too. And if you work with experienced engineers, it will really help. So those are the things. So when you now do that on a live project, it's very good because you understand exactly by the time, when you are doing your model review, even as of consultability review, all those things is very key. When you are doing that, you have to bear that in mind. When you are doing even consultability review, you see from the construction side, when they are doing construction, you see the hydro test, even the what's it called, the support, temporary support that sometimes they add just to install certain things, and even the wet point, everything is very key to stress. Because if you don't analyze well, when the cool springing and all those things, forcing some pipe in, when you don't, when the if for brown feed, if you don't do your stress well, if you don't design well, if it's not accurate, it's going to be bad, because they will, I know the construction guy will just do some kind of maybe force fit, and a lot of things will happen to change your analysis because it's not according to what was designed. So that's the from our take home. I think we have to stop there for today. Any other question from anybody? Thank you for coming. It's so hard to do this online something because of the workload. Working from home has not been easy. So a lot of workload, but we just have to, because the event has been fixed. So we just have to find a way of doing it. Thank you very much.
Thank you, sir. We
Thank you,
appreciate.
everyone.
Thank you for your lecture. We hope to join you again in class in lesson 2 or class 2.
Okay.
Thank you, sir.
Thank you very much. So we hope to do better in our next lecture.
Yes, sir.
Thank you. Yeah, you're welcome.
Thank you, Chief Lemiru.
Thank you, sir. You're welcome.
Sorry, I joined in late. I was in another meeting, but
Oh, okay.
next time I look forward to joining again. It's Bukar from
Buka. Oh, it's Buka. How is it now? How is everybody over there?
Long time, long time.
Wow,
Everyone is
wow.
fine.
Oh,
Yeah.
welcome. You're welcome. Welcome.
Yeah.
Yeah. All
Please
right.
do let me know ahead of time. I'll try and
Oh,
join the next
okay. No
next
problem.
session.
No problem. All right.
Thank you.
Thank you very
Have
much.
a nice day.
All right. Okay. So output from Word.